Okay, this week we're going to discuss thunderstorms and some of the consequences of thunderstorms, one of which is tornadoes. So we've worked our way from each of the variables that impact weather to looking at the planetary circulations to looking at the weather around here. And now we're going to look at a smaller component, a mesoscale component called thunderstorms. So each week we've progressed downward in size, and these thunderstorms are not that big in reality. So what conditions in the atmosphere favor the development of convection? Well, let's just look at a thunderstorm for a minute. I want you to see the scale of this thing. They only start out as a towering cumulus cloud, maybe 3 to 5 miles across, and they grow to maybe 10 miles across. This is the size of a thunderstorm. When we were dealing with planetary circulations, we're, thousands and thousands of miles across. Then we went down to fronts, which may be 500 to 1,000 miles or more, and even extratropical lows. Now we're dealing with something that's only 10% of that size. So think about, we have difficulty forecasting fronts and their extratropical lows are going. Think about the difficulty in trying to forecast where one individual thunderstorm is going to develop. And you can see here the life cycle of it. Warm air going up. We need instability for any thunderstorm. And plenty of warm, moist air going upwards. Eventually, some of it is going to begin to rain. That's going to push the air down. And eventually, there's nothing but a whole bunch of cold air, cooler air coming down, we'll say. So with that, this life cycle is only 30 minutes, maybe an hour. So an individual thunderstorm would typically last, if it just developed and rained itself out at your house, 30 minutes to an hour. No more. So why sometimes do we get so much more, many more thunderstorms than that in a day? Or why does there seem to be this constant line of thunderstorms or area of thunderstorms sometimes? So that's what we're going to look at today a little bit. The thunderstorms form as an individual cell, which was just that one was, multi-cell clusters or multi-cell lines, like a squall line, and then they're individual supercells. These are the ones that really cause severe weather. They have the highest threat of tornadoes occurring out of them, and they can cause tremendous damage. And yes, they do occur all across West Virginia and the eastern part of the United States. So here is a multi-cell cluster. The southern end of the line or southern end of the cluster is where the thunderstorms begin. And they gradually develop the further along to the north that line they go to where they reach a maximum and then begin to dissipate. But in the meantime, a new one has developed to the south. So there's constantly a new one forming on the southern end. That's what keeps the line moving, keeps them organized, and keeps them together. And this is where you can get prolonged thunderstorms, for example, at your house. What are some of the conditions you need? We need a maritime tropical air mass. We need moisture and heat. That is supplied by a maritime tropical air mass. So with that, we need instability as well. There needs to be some form to accelerate the air upwards. And a source of lift, usually along a front, maybe along a mountain slope. In West Virginia, I have seen winds coming in from the east or even from the west, hitting the Appalachian Mountains, go upwards and cause thunderstorms, especially in the summertime. And the more humid the air is, it doesn't take a lot of lift to destabilize it. So solar heating definitely drives it. Most of your thunderstorms are going to occur in the warmest part of the day. However, there is a nighttime maximum in the Mississippi, Missouri River Valley sometimes. And that's due to a low-level jet. We talk about jets, streams in the atmosphere. Well, this one occurs around 10,000 feet. And it seems to develop in this early spring to midsummer across this area on some days. And when it does, it transports a tremendous amount of moisture north in the nighttime out of the Gulf of Mexico, and this causes thunderstorms to develop. Thunderstorms frequency is expressed in thunderstorm days. If you have lightning or thunder on a given day, that it counts as one day. And here you can see there actually is, on the southeastern side of West Virginia, a little bit more thunderstorm activity. But overall, 30 to 40 thunderstorm days a year, probably. Some areas, maybe more than that, a little bit. The further south you get, the more thunderstorm days you get. And yes, there are even thunderstorm days all the way up into Alaska and along the west coast of the United States. But again, you see they're much less. So we've talked before about the climate and about the weather as far as global patterns. Well, remember on the eastern side of a continent, we have warmer water, warmer air, more moisture. So that's where the thunderstorms are more likely. And in the United States, we have the Gulf of Mexico to help pull the moisture up into the mid part of the country. We talked about the mountain ranges. Well, look where the Colorado, there's a maximum of thunderstorm days right along the eastern slopes of the Colorado Rockies. Mountains do influence this. Down in Florida, we have two sea breezes. We have one on the Gulf and one on the Atlantic. And I have seen, when I went to Florida State and other times I've been to Florida, you can actually watch these thunderstorms develop along these sea breezes. They may merge together in the middle of the continent, of the peninsula, or they may move west or east depending on which one is the stronger sea breeze that day. And that is something I learned the very first week I was at Florida State. Was I didn't know that much about meteorology, and I discovered that I thought, oh, here's these thunderstorms to my east. I'm going to have a nice dry walk back to my dorm. Well, at that time of year, thunderstorms move from east to west down there. I did not have a dry walk back. I got soaked. What are severe thunderstorms? Well, severe thunderstorms by definition, and this definition was created by the National Weather Service in coordination with emergency managers, getting input from the public and all. 58 mile per hour or stronger winds. Hailstones of at least 1 inch or more. That's the definition for a severe thunderstorm. Now, thunderstorms can also produce flash floods or tornadoes. So what drives a severe thunderstorm? Well, we want a thunderstorm to maintain itself and last longer than that half hour that we talked about. Vertical wind shear is the key to that. A decent vertical wind shear will keep the warm air coming into the storm, help to keep the storm upright so that the downdraft where the heavy rain is occurring stays to the west of the main warm air coming in on the east side. So you're looking for that shear, vertical wind shear, to maintain that. And the stronger that is, the better that updraft can maintain itself. And if it gets strong enough, you may actually get supercells. Here you can see a very classic pattern for a severe weather outbreak in the Midwest or western part of the Midwest here. Notice the strong low-level jet coming out of the Gulf of Mexico, pulling moisture up. You have a large jet stream to the north, up to the upper levels coming in from the southwest. Oh yeah, and at the very surface you may be getting moisture in off the Gulf of Mexico, and you're mixing in dry air from the west. The dry air from the west and the warm air from the east, when they collide, you got a front. And that dry line can actually be a front as well. It may be really hot to the west there of that line and may not be as cold as behind the main cold front, but it could be a very dry area. And that dryness can actually cause lift. Another thing, you want to get it as hot as possible at the surface. Well, down in the tropics, it is very moist. You do not see this stable air very often. So what happens is you get a lot of cumulus develop and your thunderstorms go up. And you get heavy rain out of it, but you may not get a lot of severe weather. But in the Midwest and even around our area, sometimes you get this inversion. What happens is you'll get cumulus clouds that go right to here and they'll just stop. They don't go any further. As the day's heating takes place, they keep getting hotter and hotter. Eventually, the temperature is over here somewhere, and then you break that inversion and these thunderstorms just take off and skyrocket upwards. That means they really accelerate. When they really accelerate, they'll be able to reach really large heights, and you get severe weather out of them. So one of the things meteorologists do look for is this stable layer sometimes, especially if it's fairly cool and dry above that, because remember, I'm mixing warm, humid air. I'm condensing it. I am creating heating. I am really sending an air parcel up there that's way, way warmer than the surrounding environment. So it is very unstable. Within a cloud, lightning is another problem that too many people die from lightning every year because they want to watch it. And it is beautiful to see, but it is very dangerous, and it comes out of the tops of updrafts. And what's really fascinating is that graupel, which is kind of like an ice-water mix that forms in many clouds. Ice crystals form. What happens is temperatures of less than 5 degrees, graupel becomes negatively charged. So if there's an ice crystal with some water around it, that's negative. All of a sudden, something that's pure ice becomes positive. And remember, the pure ice is getting a little lighter, so it's getting pushed in the upper part of the cloud. Now, if the temperature is greater than 5 degrees, everything flips. Positive charge becomes the graupel, negative charge becomes the ice crystals. So that creates two sections of charge within a thunderstorm. Kind of looks like this. And with that, you can get a lot of lightning develop in the mid part of the thunderstorm first, where the most charges occur. And then eventually they come down to the ground. So a lot of thunderstorms have lightning in the cloud initially before they have it on the ground. And one of the things meteorologists are now trying to do, especially for beaches, is try to find when that lightning is beginning to occur in the cloud or may occur, so that we can issue a warning or at least a statement for the beachgoers to get off the beach, because they are the highest object on the beach. They're in umbrellas, they're standing there, there's nothing but flat sand, so they could get hit by lightning very easily. Trees are wonderful spots for lightning to come down. Downbursts are another problem. We talked about that cool, moist air that comes down on the one side of the thunderstorms where the rain is occurring. It gets cooler as it's coming down because of the rain occurring in it. It's sinking, hits the ground, and when that hits the ground, it has to go somewhere, so it can't go straight into the ground, so it goes both directions. And if you're an aircraft, that's not a good thing, because what happens is the aircraft's coming in, maybe this occurs along a normal flight path. Well, all of a sudden you got great lift for this aircraft, so maybe it's going to lift upwards. Then you get on the other side of it and you have no lift whatsoever, because all of a sudden you have all this wind that's coming the same direction your aircraft's moving. So the aircraft's wings have no lift. So what happens is, too often in the past, aircraft have crashed because of this. They still do sometimes, because they're not aware of the weather around them. And these can be very small, very short-lived. Many major airports right now have what they call Doppler radar that's made for downburst. So it's a terminal Doppler radar. They determine it. It looks specifically for these kind of events, and it's very small scale. It's looking at basically around the airport in the glide path, but it's looking very low, lower than normal traditional Doppler radars of the National Weather Service, and it can pick out these downbursts very well. Derechos are straight line winds. You had some in West Virginia. I remember reading some of your memorable weather events were about a derecho. And they are just really a mesoscale convective system that develops with this line of thunderstorms. And the one that, for example, that hit West Virginia developed out by Chicago early in the morning moved east, the one many of you talked about, and eventually came to West Virginia during the heating of the day, during the late afternoon and evening hours. Notice how far that came, all the way from Chicago, and it wound up going all the way off the east coast of the United States and caused damage all along the way. There have been some spectacular derechos that have occurred that have gone even longer than that and caused tremendous damage along their path. Sometimes in derechos, you can get winds gusting over 100 miles an hour. Bow echoes are a part of derecho. What they are is an echo on thunderstorms that looks like it just bows out ahead of the rest of the line of thunderstorms. When you see that on radar, that's an area for potential severe weather. And here you can see an example of that. And you can see the winds are pushing outward more. And basically, it's causing a better chance for tornadoes and a better chance for severe weather. Here are some of the most notable wind events of some of those derechos as well, some other ones. All right. Thunderstorms have to have a lot of moisture to go. So if they have all this moisture, some of that moisture is going to come back down to the ground as rain. And that's what causes flash flooding, because they many times, especially in the summertime, may not be moving that fast, and they may produce rainfall rates of 3-4 inches an hour. There have been reports of over 5 and 6 inches of rain in 1 hour from a thunderstorm. And that has occurred in West Virginia mountains, some of that kind of rainfall. So think about it. If you're sitting on a mountain slope and you get 4 to 5 inches of rain, all that water is rushing down. Those little tiny rivulets and streams that are there are going to just burst out of their banks, and they're going to take trees. They're going to take half the mountainside sometimes down, which has happened on the east side of the Appalachians as well. And flash flooding is a major problem, and it does cause deaths. The Big Thompson Canyon, I lost a friend in that one. And what you need to do to remember flash flooding is you've got to get above the level of the water. West Virginia mountains, if you can climb up just a little bit, sometimes you get above where the flooding occurs down in the valleys, down in the hollers, as I was taught when I lived in West Virginia, and I still have relatives there that will tell me that. Hail is a big part of thunderstorms. And remember, I said they have to be at least 1 inch in diameter. That's not real tiny hail. That's fairly decent size. Hail just grows by going back up. Remember, there's a circulation in that updraft that keeps pulling this water upwards, freezing it. Then it maybe comes down a little bit in the rain shaft and gets pulled back into the updraft. And if it does that enough times, it gets pretty heavy, and eventually it can get pretty big. And hail cores, you can really pick them out now with dual pole radar. They show up at the big higher level of the clouds, and you can actually watch them come down to the ground and put out hail several miles downstream from where the initial development occurred. Tornadoes, they're the worst part of a thunderstorm, and they do occur. Many thunderstorms are supercells. There are definitely a number of those that occur every year, but only about 10% of the total thunderstorms in the U.S. and a small percentage of supercells turn into tornadoes. The idea is to figure out which ones and be able to forecast them. Tornadoes can be fairly weak, maybe less than a mile long, and just kind of hop down, tear up a chimney or two, and go back up, or violent and actually wipe out houses where there's nothing left. Not even the foundation is left sometimes in the most violent tornadoes. There are two main areas for tornadoes. One is a north-south corridor. We looked at that earlier, where the wind shear and the great southerly jet was going on in the Midwest, and that's Texas through Nebraska. There's another one more to the southeast of that area, which is Mississippi through Florida, northern Florida, basically. And both areas don't have a lot in the way of mountains. They're fairly flat. So you wind up getting most tornadoes actually occur in May and June is the actual time. Now, West Virginia does get tornadoes. Mountains don't totally protect you. And every once in a while, they may skip across from mountaintop to mountaintop or come down into the valley. There are actually hills around Birmingham, Alabama, where there have been EF5s that have going up a hill and down on the other side of it. And here you can see the average number of tornadoes per state, but it's a little more interesting to look at the average number per square mile of the state. And West Virginia is fairly low, but on either side of it are basically 5 each normally. And you can see the Tornado Alley right here and Dixie Alley over here. This was a famous one for warnings. It caused Joplin tremendous damage. It was warned early. This was one that the Weather Service did an outstanding job in issuing a warning before it even touched down by over a half hour in the western side of Joplin. The warning was issued for this whole area. As part of that warning, this area where the EF5 occurred was actually in a warning for an hour and a half before the tornado came. Some people went outside from a restaurant they had taken shelter in, decided the tornado must be past because it was over an hour since the warning, even though the warning was still in effect. And when they did that, they got rocked right into the path of an EF5 tornado and were either injured or some of them were killed. So the question became is how long should a tornado warning be out? It's still in discussion now. And this is an EF5 scale. It is developed originally by Ted Fujita from the University of Chicago and has been adapted and worked with now by civil engineers to design looking at property damage to determine wind speed. And every time you do a tornado survey, which is done by the National Weather Service, and sometimes in cooperation with some civil engineers, we try to estimate which one of these categories it falls into. And here you can see the supercell and the circulation. You'll actually see this week on the Oklahoma City radar out of Norman. And that EF5 that occurred had a tremendous low-level circulation. And you can see here the wall clouds. Wall clouds are just where the rain has come down around the edge of the wall cloud. It moistened the air. It sucks back up into the tremendous updraft that's there so that the actual clouds form at a lower elevation. And when they do that, they're also very flat. They tend to be, but they also tend to be rotating around, and that is where the tornadoes can develop. And here you can see one on Doppler radar. Here's the hook echo. And here you can see very strong change of wind direction between each other. So with that, we'll take a quick peek. There's not a lot going on today on tornadoes, but I wanted to show you we can actually detect lightning now on tornadoes. And that there are some lightning strikes down off of the Florida coast right now. That's the only area in the country that really has any lightning or any instability right now. And you can see them down here right off the Florida coast. Not a lot, but there are some lightning strikes down in that area right now. And if they turn towards red, there's more lightning occurring than just pure yellow. So SPC, wonderful place to look at a sounding, and you can see here last evening, fairly moist sounding out of Miami area, and parcels heated up would rise along the moist adiabat. So there was lift, and there was some. It did produce some thunderstorms down there. And finally, you want divergence aloft. We've talked about that. Tremendous divergence right now going along the East Coast where this low is developing. So there's maybe a chance of more thunderstorms further east off the coast of the United States. So hope you got something out of this, and let me know if you have any questions.